Today I will talk about how to implement RAG in N8N using the local PDF files. This is part of my series of lectures on Agentic AI. I am interested in business analytics and generative AI. This is my personal website and this is my Google Scholar page. This is outline of my lecture. First I will give introduction to RAG. Then I'll talk about installation considerations. Then I will describe two workflows, one with temporary storage of embeddings and the other with permanent storage of embeddings. Retrieval augmented generation or RAG is an AI method that improves response accuracy by fetching facts from external data sources before a language model generates an answer. These are the key architectures I will describe in detail later. RAG connects a large language model to outside data like company files, databases, or web pages. These are the steps. First one is data preparation. Documents are split into small text blocks and changed into numbers, which are known as embeddings or vector embeddings. Next step is retrieval. When we ask a question, the system searches for text blocks that match the meaning of our question. Next step is generation. The system gives our question and the found text blocks to the LLM to generate a factual answer. This process of consulting the local data stops the model from making things up or stops from hallucinations. These are the types of RAG. One is naive RAG. This is the basic setup. It does a single search for text blocks and immediately creates an answer without extra checks. Graph RAG. It uses a knowledge graph to map out how different topics and words relate to each other, improving complex research tasks. Agentic RAG uses an AI agent to plan steps, break down hard questions, and search multiple times or use tools until it finds a good answer. Today I will describe agentic RAG. Then corrective RAG, it checks if the retrieved facts are actually good. If the data is bad, it fixes the search and looks on the web. Multimodal RAG, it handles different types of media like images, charts, audio, and video alongside text. Adaptive RAG, it automatically decides whether a question needs a fast, simple lookup or a deep multi-step search. So what are the benefits of retrieval augmented generation? It reduces factual errors, grounds the model in real documents instead of guessing from memory. No retraining needed. We can add new files to the database instantly without spending money to retrain the AI model. Cost effectiveness. It is far cheaper than fine tuning a model for fresh updates. Now, installation considerations. We assume that you have already installed the desktop Docker. So we start Windows command prompt in administration mode and we run the following command. This is to install Postgres or PostgreSQL. For my present lecture and present workflow, we do not require Postgres. However, I always describe and recommend to install Postgres before installing the N8N. This is the installation of Quadrant. This is required for persistent storage of vector embeddings. This is the command to install the quadrant. These are the ports, and this is the volume. And this is very important. We need to set the service API key so that we have both read and write permissions to the quadrant. And these are the images. This is to install N8N along with Postgres and permission to read the local files. So this is how we mount a local directory, and these are the permissions for read and write settings. Now let us see the workflow where there is temporary storage of embeddings. This is the workflow which I have created. Initially, we need to run this part. Later on, for use, we need to run this part. So let us see one by one. So this is the first part where we read the local files. So for that, we need the read-write files from disk node, and then we connect it to insert data store. This insert data store uses the default data loader and the Gemini embeddings. I'm using the Gemini embeddings here. So this is the part where we read the local files, convert them into vector of embeddings, and for that we need Google Gemini embedding service. This is the next part, or this is actually the RAG part. Here we have a chat trigger. So this is how we ask question to our agent, and this is the chat model here. I'm using Gemini, and this is the query data tool. It queries the Gemini embeddings here, and this is how our AI agent does the retrieval augmented generation with the help of these embeddings and chat model. So let us quickly go through the settings. This is our read and write files from disk node. So this points to our virtual directory here, and this directory corresponds to the actual path which we have mounted, and in that actual path we have placed our PDF files. Then this is the insert data to store. Here just we specify the memory key as vector store key, and this is the embedding batch size. Operation is insert documents. This is the default data loader. Data type is binary, and these are the further settings, and it does the text splitting itself. This is the embedding Google Gemini embedding node. Here we need to set our API key, that is the Gemini API key. This is the next part, which is the actual RAG. Here we use the AI agent and a chat trigger here. In the AI agent, we have the user message from the chat trigger. So this is the code here. This is the chat model which we are using. It just needs the API key here from Gemini. This is the query data tool. It is actually a knowledge base, and we need to just specify here as memory key, which we have already set there previously. So this is how workflow 1 works. First of all, we read the local files and create vector embeddings. Then whenever we ask question to our AI agent, it uses the chat model and the vector embeddings. And these embeddings, they persist until our session. Whenever we restart the N8N, these actually disappear from the memory. Now let us see a workflow with permanent storage of embeddings. So this is the workflow which I have created. It again have two parts. This is the first part where we actually read files. After reading the files, we get the binary data and we convert the binary data to text, and then we extract the text using the code node here. Then we do the vector embeddings with the help of the OpenAI embeddings here, because I tried but I failed to use the Gemini embeddings because of the vector size problem. So I need to use the embeddings by OpenAI here. This is the paid part actually. I have paid for this service, and for the storage of embeddings, we use the quadrant and we also use the text splitter here. This is actually the RAG part in working. We have the AI agent attached with the chat trigger, and this agent uses the chat model. I use Gemini, and this is the memory store, and it is again a temporary storage here. This I have used only to store the conversation temporarily, and this part actually store the embeddings permanently in quadrant, and then we search the documents whenever required. So this is the first part here, that is the retrieval augmented generation, which I have already described. This is the part where we read the local files and do vector embeddings. This is the setting of read and write files node. Here we just point out to our virtual directory and the PDF files. This is the node to extract text from binary, and this is the parameter here. This is the code to extract the text. This is the insert into vector store where we use the quadrant database. We use the API key here, which we have generated before. And this is the local file content and metadata. Here we do two things. First, we need to get the main text from the code extract text node. Let me show you. This is the code extract text node. From here, we retrieve the text of the document. And from this node, read and write files from disk, we retrieve the metadata. So we retrieve two informations from two different nodes. One is the code extract node where we retrieve the text, and the other are the metadata information which we retrieve from read and write files node. Then we use the text splitter. This is the parameters for text splitter. And this is the AI agent node which is connected to the chat trigger. So this is the prompt which we get from this chat. This is the chat model here where we need to supply the Gemini API key. This is the store conversation. This is a temporary storage here, and it remains for the session ID. This is the search document node where we use the quadrant database and we supply the quadrant API key. This is the embedding from OpenAI, and where we supply the API key, we supply, this is optional, the organization ID, and this is, we input here the base URL in this form. So this is our workflow with permanent storage of vector embeddings. This is all for today. Thank you very much.